Okay, as we start moving into infinite values for x and y, we're going to be using a lot of different functions and evaluating their answers. We're going to evaluate what does the answer become if you plug in an x value of 2. And because we're going to be doing this so frequently, we actually have some new notation that can represent x's and y's, or a and b's, or g and h's. It can represent any input and any output. And I'll show you it in a moment. It's going to look like this. But quick terminology, if you're asked to evaluate a function, that means you are plugging in an x value. You are plugging in, and it doesn't have to be an x, it could be an a if you're plugging in an input value. And you are getting out, or you are you're plugging in an x value, and you are evaluating to obtain a y value. So how does this look? Example 3. Example 3, you're asking to evaluate the function when x is 2 and evaluate the function when x is 4. So this tells you your x value, your x. F at 2, the answer to what you do to x is like your y. So a lot of people like to look at f of x as just your y value. They just sometimes call it y. So let's look at letter A. Letter A, it says here's your function, negative x squared plus 1. Evaluate the function when your input value is 2. So what I'm going to do is I'm going to rewrite this function here and just replace x with 2. So I have the opposite of 2 squared plus 1. And we know that we have to do exponents before multiplication when simplifying. So 2 squared is 4. The opposite of 4, or negative 1 times 4, is negative 4 plus 1. Comes out to equal negative 3. So all we're saying here is when x is 2, y is negative 3. Or in other words, when you evaluate the function at 2, you get an answer of negative 3. Some people like to list it as a coordinate, saying, hey, when x is 2, y is negative 3. Well, another way you can do that is say, well, that would be a good way to do it, just list your ordered pair. But this is more often the terminology you'll see in the book and on ACT type preps. So let's try f at 4. F at 4 means take the function and you're going to plug in an x value of 4. So we have the opposite of 4 squared plus 1. We know this means simplify, evaluate. So 4 squared is 16. Negative 1 times 16 is negative 16. Negative 16 plus 1 is negative 15. So the function, when you plug in 4, comes out to equal negative 15. If you looked at it as an ordered pair on a graph, it would look like 4, negative 15. Okay, try example B, and then we'll do C together. Okay, so hopefully you found that the function, when you plug in 4, comes out to equal 12. Let's try letter C. This is supposed to say 9 divided by all of 1 minus x. So we know our x value is 2. We go ahead and place that in. 9 over 1 minus 2. Now remember, your numerator and denominators are grouped like they're in parentheses. So let's do the parentheses first. Let's do that denominator. 9 over negative 1. Comes out to be negative 9. So this function, when you plug in 2, is equal to negative 9. Let's try the next one. 9 over 1 minus 4. Do the denominator first. So that's 9 over 1 minus 4 is negative 3, which comes out to equal negative 3. So this function, when you plug in 4, is equal to negative 3. Alright, so we just really want to hit home on this new notation because we're going to be using it so often. So try these three. Evaluate the function for x is 3 and x is negative 4. So we go ahead and do that if we're evaluating what is this function when you plug in 3. It's equal to the opposite of 3 squared plus 1. That's negative 9 plus 1, negative 8. So this function, when you plug in 3, is negative 8. When you plug in negative 4, it's equal to the opposite of negative 4 squared plus 1. Keep in mind, do the exponent before you multiply by this negative 1. Negative 4 squared is 16, but negative 1 times 16 is negative 16. Negative 16 plus 1 comes out to equal negative 15. And moving right along, g of x here we have. So let's try this. G, when you plug in 3, is equal to the absolute value of 5 times 3. So we know that that's equal to 15. G, when you plug in negative 4, is equal to the absolute value of 5 times negative 4, which is the absolute value of negative 20. That comes out to be 20. G, when you plug in negative 4, is 20. And then we're going to skip this one because it is similar to letter C, and you can refer back to letter C to see how to do that. But do be aware, functions might have different names. It might be f, it might be g, it might be h, but they all represent the same thing. You are taking a function, plugging in a value for x, and seeing what comes out. Alright, let's flip it over. Okay, so we have evaluated this by hand. Now let's take it to a graph. It says evaluate the function shown below for f at 4. So remember, this is your input value. This is your x value. So all we're asking is when x is equal to 4, what comes out? And here's how we look at it on a graph. First of all, there's two functions shown. One is f and one is g. We have to pay attention to which one the problem is asking for. So the first problem is asking for f. So we're seeing when x is 4, remember, that's your x-axis, that's your y-axis. So we're going to move over to 4. When x is 4, what comes out for function f? And at x is 4, function f becomes 6. So what's the answer here? 6. Try f at negative 5. So when x is negative 5, the function comes out to equal 7. So we have negative 5, 7. So what is the function when you plug in negative 5? 7. Now we're moving to g. When you plug in x is 0, see what comes out for function g? Negative 5. When x is 2, go ahead and try these three on your own. And then hopefully you can see how to read a graph using that function notation, and there should be your answers. Okay, so what we're going to do after we look at more and more functions is we're going to really be focusing on their graphs, because the graph is the only place we can show all of the solutions for x and y. So let's go ahead and let's take a look at this function, and we're just looking at 5 answers for x and y. So if I plug in negative 2, what am I going to get out, which will allow me to make a point on my graph? Well, we know by now that means plug in -2 for x. So the function at -2 is equal to -4, I'll do that in a different color, times -2 plus 3. That gives us 8 plus 3, which is 11. So I can graph the point -2, 11. And this is going to kind of go off my graph. -2, 1, 2, 3, 4, 5, 6. It's way up there. We'll just go ahead and write it in there. -2, comma 11. Okay, let's try another one. -1. When I plug in -1, I have -4 times -1 plus 3. Gives me 4 plus 3, which is 7. If you'd like to, you could write it as the ordered pair you're graphing, -1, 7. So I'm going to go -1 up 1, 2, 3, 4, 5, 6, 7, like right here. Plug in 0, -4 times 0 plus 3. 0 plus 3 is 3. You could write the ordered pair you're graphing, 0, 3. Right here. Plug in 1, -4 times 1 plus 3 gives us an answer of -1. So we have 1, -1. 1, -1. And then lastly we plug in 2. -4. Gotta follow my function. -4 times 2 plus 3 equals -8 plus 3, which is -5. So we have the ordered pair 2, -5. 1, 2, 1, 2, 3, 4, 5. 2, -5. Okay, if I take a look at this ordered pair here, I'm told that this is a function. That means if I use the vertical line test, I know that the line would not pass the graph more than once. And if you're told that you have a function, you are going to have infinite solutions for x and y. We just gave five solutions. Let's see if we could, and the way that you can determine more is you can continue plugging numbers in for x, or you can connect the patterns that you see, and this will give you all the infinite solutions for x and y. Even when x is 1/2, then you're going to get a y value equaling to 1. So now you have all of these x and y's. So the last piece is give the domain and the range of the function. The domain, again, are all the x values. If I'm just listing the domain that was listed here, I would have -2, -1, 0, 1, and 2. The range would be my answers, 11, 7, 3, -1, and -5. But if I connected everything on my graph, I'm going to see what are all the possible x values that could be graphed. We can plug in 1/2. We could plug in -1, we did. -2, we can plug in -3, -4, -5, -6. So actually our entire domain for this function would be -infinity to infinity. Our range, what are all the y values we're getting out? We're getting out values like 11, 7, 3, -1, -5. And because we know that this is a linear function, it keeps going, we know that the y values are going to go to infinity, and the downward y values would go to -infinity. So our range would be -infinity to infinity. Okay, try this next one on your own. Since this is a function, we have these 3 points. We know that the function keeps going. Why does it?
The following students, please come to the front office. Brandon Backload, Emily Andrew, Elizabeth Sear, Jessica McElwee, Amanda Teagle, and Hope Somed-Lekgati.
Okay, why do I know there's no other x's this way? Why did I not connect the graph this way? Well, we can see when x is negative, we can't have square root of negative numbers, so there's nothing to graph. So our domain, our x values actually start at 0 and keep going at 1, 2, they could keep going 3, 4, 5. They keep going up to infinity. So my domain would be 0 to infinity. My range starts up here at the y value of 5. So I actually have values from 5 to infinity. And we're going to talk more about the domain and the range in the future. Right now you want to be looking at your x values for the domain and the y values for the range.